Okay, this lesson is on solving polynomial equations. Solving polynomial equations is going to use a combination of your graphing calculator as well as your skills in synthetic division. With the lesson or a couple lessons ago, you learned about synthetic division and how we can use synthetic division to find factors and stuff like that. You learned it with factoring in the last lesson. So we're going to sort of combine everything here with solving polynomials. So it's pretty straightforward. For every single problem, you're going to do essentially the exact same thing. It's just when you get, after you run synthetic division, you'll either have two choices to make. And so the first step here that we're going to do is the same for every other problem. So, step one, we need to find one of our solutions to run synthetic division. So what we need to do in the first step is plug our equation into the y equals in our graphing calculator and find one of our whole number solutions. Now the key is that it has to be a whole number solution. So we're going to look at the very first problem here. Okay, and I'm going to go to y equals, and I'm going to put the first equation in, which is x to the third minus 9x squared plus 20x. And I'm going to hit graph. Now, a lot of times it is very obvious what your whole number solution is. You can see here that it looks like it crosses at 0. Now we can verify this if you just hit the second button right here, second, and go to graph and look at your table. Anywhere where the x value or the y value is 0, that is an x-intercept. So you see that you have it here at 0. You also have one at 3. And you have one at 4. So in this case, because one of the things that I don't know if I guess we haven't mentioned this yet, but one of the things that you should know off the bat here is, this is an actual rule, but whatever the exponent is, because this is x to the third, that tells you that you're going to have 3 solutions. Now, if I look at my graphing calculator and I can see all 3 solutions, they're all 3 whole numbers, then I don't need to do anything else. I know all 3 of my solutions. They're right there, 0, 4, and 5. Remember, your x-intercepts are where y is 0. So anywhere where you see y is 0, which is here, here, and here, at 0, 4, and 5, those are your solutions. So I can go right to x equals 0, 4, and 5. I don't need to do anything. So you will have problems like that where all of your numbers are whole number answers. Okay? Anytime that happens, you don't need to do any more work. Well, that's only one problem. So let's look at a different one. Let's look at this one. Okay? Again, I'm going to place this into my graphing calculator. Let me slide this over so we have room to see everything. Go to y equals, and I'm going to put this in my graphing calculator. So I have 8x to the third minus 2x squared minus 43x plus 37. And I should have everything in there. And we hit graph. So this one looks like it might be a little bit more complicated. It looks like it does go like in between some lines here. And you can look at it on your own graphing calculator, but we're going to verify this. So we're going to go to the table and see what I got. It looks like the only one that I see that is a whole number is right here, and it's x equals 1. That's my only option. You will always have one, at least one. So looks like here that one of my x-intercepts is at x equals 1 because that's where y is 0. So here's what I do. Step 1, I found a whole number solution, so I'm going to use it. 1, I place it in synthetic division. Bring the numbers down of 8, -2, -43, 37, and I'm going to run synthetic division. First number comes down, so 8 times 1 is 8, -2 and 8 is 6, 6 times 1 is 6, -43 and 6 is -37, -37 times 1 is -37. If you did the synthetic division properly, you should get a 0 at the end. There should not be a remainder. Because you're using an actual solution, you should get a 0 because it's a factor. I'm using an actual factor of this equation, so I should not get a remainder. Now here's the sort of, I guess I would call it fun. I don't know what if you would call it. Here's the fun part. So what happened is that this was an x in the third, so now this is an x squared. So now I have 8x squared plus 6x minus 37. So the question is, well, Mr. G, I know that I'm supposed to have 3 solutions, but I only have 1. It's right there. How do I find the other 2 solutions? And this is what synthetic division allows us to do. Now it has made this a quadratic equation. And now I know how to solve any quadratic equation using a specific formula. And that is the quadratic formula. So we're going to use the quadratic formula to find the other 2 solutions. Okay, slide this over a little bit. I'm going to do the quadratic formula right over here. So opposite of b is -6 plus or minus the square root of b squared minus 4 times a times c. All over 2 times a, or 16. Now, when doing the quadratic formula, what I told you is you always do the discriminant first. So in my calculator, I'm going to do 36 minus 4 times 8 times -37. And it looks like I get 1,220. So -6 plus or minus the square root of 1,220. And you just do a real quick check and see if that's a perfect square. It's not, so there's your other 2 answers. Recap. Let's recap that problem. A lot there. So we started with going into our graphing calculator and finding one of our solutions. And we found it, and you can use any of them. Sometimes there's multiple. You just choose one. So unless they're all there, in that case, you just write them all down. But in this case, only 1 came up. So I'm going to use that 1, literally 1. The number 1 came up. So I'm going to use that, and then I ran it through synthetic division to simplify the problem. Now it's simplified into a quadratic function, and then here's your 2 choices. If you get a quadratic, after synthetic division, if you get a quadratic function, you have to use quadratic formula to find your other 2 solutions. Now the reason why this is 2 solutions is because of the plus or minus. One solution would be -6 plus radical 1220 over 16, and the other solution would be -6 minus radical 1220 over 16, and our third solution is 1. Now, what's the other, Mr. G? What's the other thing that could come up? Well, you either will do this and get a quadratic and you use quadratic formula, or this is the other type. Let's look at number 8. Number 8, once again, I'm going to plug this into my graphing calculator. Let's slide that over so I can see both here. Clear out y equals, clear that out, and I'm going to put that in my graphing calculator. So y equals x to the 4th minus 12x squared plus 32. Graph. Now what we're going to see are you have 4 solutions. Clearly it crosses the x-axis 4 times, so I have 4 solutions. Well, it's kind of hard to see, so let me verify this by going to my table. And it looks like my y, I have 1 here that I have visible right now. It's right there. It's where my y is 0 at x equals 2. So I have one solution that I can use. So I'm going to use 2 and run it through synthetic division. Now this one you got to be careful because it skips some numbers. I do have an x to the third missing and I have an x missing. So I do have to use 1, then 0, then negative 12, then 0, then 32. Run this through, 1 comes down, so that's 1. 1 times 2 is 2, 0 and 2 is 2, 2 times 2 is 4, negative 12 and 4 is negative 8, negative 8 times 2 is negative 16, negative 0 and negative 16 is negative 16, and 2 times negative 16 is negative 32. Good, I got a 0 at the end, so I did everything right. Now, because this was an x to the fourth, this will drop to an x to the third. So I have x to the third plus 2x squared minus 8x minus 16. Here's the other thing that happens. When I did the previous problem, I got a quadratic. And therefore, I used the quadratic formula to solve. This one, I actually get a cubic. And there's 4 terms. Can you guess which way you use to solve a cubic that has 4 terms? Well, if you guessed grouping, then you're right. Ding, ding, ding. You're going to use grouping to solve this. We group our first, second. So, again, quadratic, use quadratic formula. Cubic, use grouping. That's your 2 options. Use the calculator to find one of your solutions. Run the solution through synthetic division. If you get a quadratic, use quadratic formula. If you get a cubic, you use grouping. So I'm going to use grouping. Here I'll take out an x squared, which leaves me with x plus 2. Here I'll take out a negative 8, which will give me x plus 2. I know I did that right because both of my parentheses are the same. So I'm gonna continue over here so I have some space. I combine the 2 GCFs into x squared minus 8, and then the common factor of x plus 2. Now I'm not quite done because the goal here was to solve, right, to get answers here. So I'm going to set each of these equal to 0. X squared minus 8 equals 0, and x plus 2 equals 0. When I add the 8 over, I get x squared equals 8. So I square root both sides, and I get x equals plus or minus the square root of 8. Now you could simplify that. You know, that simplifies into 2 radical 2, but I'm okay with you leaving it like this. This one, when I subtract the 2 over, I get x equals negative 2. And there are my 4 solutions. 1, 2, and 3, and 4 with the plus or minus. That is solving polynomials. Okay? If you'd like to, or if you have room and you want to, go ahead and try to do number 10 on your own. Put it in your graphing calculator, find one of your solutions, and then run it through synthetic division. You're going to end up with a grouping style problem just like the previous one, so you can use the previous one as a guide to walk you through how to solve it. And if you want to check your answer, go to do the problem, pause your video, and then just come up to me and let me know. I can go through the problem with you. We don't have time on the video here to do that, but we can walk through the problem together if you want. If you want to pause the video once you're done, and I can go over it with you. Same thing happens in this last problem too. If you want to do that, it's the same thing. Basically, you have 3 types of problems you can get. 1, you plug it in your graphing calculator, and all numbers are visible. All numbers are whole numbers, and you just literally write them down. Other option is that not all your numbers are there. Only at least one is there. So you have to use your one solution, run it through synthetic division. If you get a quadratic, you use quadratic formula. If you run one of your solutions through synthetic division and you get a cubic involving 4 terms, you have to use grouping. And that is how you solve polynomials. Now, we can, if you go to the other side here, we can also work backwards. And we can work backwards by, given the graph or given the solutions, can we write the equation? So what we're going to do here is go through and see if we can find this. We have a solution right here. And because this just sort of touches the x-axis there, that's going to take up two solutions. So, well, let me just put it this way. It touches right there. So it looks like it crosses at 0 and it crosses at -6. So my solutions are 0 and -6. Now here's how we work backwards. Because you have solutions, solutions comes from factoring or setting your factors equal to 0. So the way we work backwards is to put these back in factored form. And how you put them back in factored form is you do the opposite sign, which in this case there's no opposite sign for 0, so just x plus 0. But here, this would be x plus 6. Keep in mind that if I were to set x plus 6 equal to 0, I would get -6. That's why you do opposite signs. So x plus 6 is in factored form. And all we do is just multiply those. So, and I'm going to do this down here in b, because these are our zeros. So x times x is x squared. X times 6 is 6x. 0 times x is 0x. 0 times 6 is 0. So I end up with this problem like this. These sort of just cancel out. So I get x squared plus 6x. Now one thing we have to take into account here, this is a cubic. And you might be like, Mr. G, how do you know? How do you know this is a cubic? Well, because I'm telling you that it's a cubic. And it says here in the problem that says write the equation of the cubic function, which means that this has to be an x to the third. So we can adjust this if that happens. We can adjust this. If we need it to be an x to the third, what can we multiply to make this an x to the third? Well, the answer is x. Yes, we just multiply both terms by x. And that's your answer. That's the function of this graph. Don't be alarmed. We will revisit that in future lessons here. We'll readdress this type of problem in future lessons. So that's it. So solving. Again, if they're all whole numbers, just write them down. If you only have one, put it through synthetic division. If you get a quadratic, you use quadratic formula. If you put it through synthetic division and you get a cubic involving 4 terms, you use grouping and solve. That's it. Thanks.